let's just see the example number 1. Example number 1 says examine whether x plus 2 is a factor of this polynomial and of this polynomial. So using the factor theorem, we will verify whether x plus 2 is a factor of these two polynomials or not. So let us suppose we are starting the solution set of this particular question. So let us suppose we are supposing the polynomial functions as p of x and q of x. So let us suppose p of x is nothing but x cube plus of 3x square plus of 5x plus of 6, and I am taking the polynomial q of x as nothing but 2x plus of 4. So let us suppose I am calling it as 1 and I am calling it as 2. So we have to examine whether x plus 2 is a factor of the px polynomial and the qx polynomial. So by the factor theorem, what we can say, with the help of the factor theorem, we can say that x plus 2 is a factor of these polynomial if, let us suppose I am recalling the factor theorem, x minus a is a factor of the polynomial only if p of a is nothing but is equal to 0. So by using the factor theorem, what we can say over here, that x plus 2 is the factor of these polynomial if and only if p of a should be equal to 0. So let us suppose I am finding out the 0 of x plus 2 is, let us suppose I am finding out the 0 of x plus 2 as x plus 2 is equal to 0. We all know how we can find the 0 of a polynomial. So x is equal to minus 2. So this is nothing but the 0 of the polynomial. So let's just substitute x is equal to minus 2 in both of these polynomials one by one. And if they are is equal to 0, then it definitely means that x plus 2 is a factor of these polynomials. And if they are not is equal to 0, then they are not the factor of these polynomials. So let's just start with the very first equation. So substitute x is equal to minus 2 in the equation number 1. So let us suppose we are substituting in the equation number 1 as p of minus 2 is equal to minus 2 whole cube plus of 3 minus 2 whole square plus of 5 minus of 2 plus of 6. Now let's just solve it. Minus 2 whole cube means minus 2 into minus 2 into minus 2. So this is nothing but minus of 8 plus of 3 into of minus 2 whole square is 4 plus minus is minus. So it is minus 10 plus of 6. So at the end what we are getting? We are getting minus 8 plus of 3 into 4 is nothing but 12 minus of 10 plus of 6. Now let's just add up the terms that do have similar signs all together. So this is minus 8 minus of 10 is minus of 18 plus of 12 plus 6 is 18. So obviously 18 and 18 gets cancelled and hence the answer is nothing but is equal to 0. It means that p of minus 2 is nothing but is equal to 0. So if p of minus of 2 is equal to 0, it implies that x plus 2 is a factor of the polynomial p of x. So for the very first part, it is all clear that x plus 2 is a factor of p of x. Now let's just check it out for the q of x. Now substitute x is equal to minus 2 in the equation number 2. Now let's just substitute x is equal to minus 2 in the equation number 2 in order to find out whether it is a factor of the equation number 2 or not. So q is minus of 2, it is equal to 2 of minus of 2 plus of 4. Minus 2 into 2 is minus 4 plus 4, it is nothing but is equal to 0. So hence at the end again what we are getting? We are getting the polynomial is equal to 0. It means that x plus 2 is a factor of the polynomial q of x. So at the end what we have deducted? We had deducted with the help of the factor theorem that if we just wanted to find out whether such kind of a polynomial is a factor of this and this, we have to follow the two parts of the factor theorem. I hope all the steps are all clear to you. So let's just move on further.